4x to the fourth plus 12x cubed plus 9x squared. So to find the zeros here, I'm first going to say, okay, 4, 12, and 9. Do those have any common factors? Bummer, they do not. What about x to the fourth, x cubed, and x squared? Then I do have a common factor. So I'm going to take out the x squared because I have at least 2 x's in each of those terms. That's going to leave behind 4x squared plus 12x plus 9. Okay, the follow-up question is always going to be, does the stuff inside parentheses factor again? Well, what I noticed when I wrote this out was that 4 is a perfect square and 9 is a perfect square, so that made me think maybe that whole thing is a perfect square. So what would we need for that? Well, we need 12 to be 2 times, okay, what's being squared here? 2 is being squared. What's being squared here? 3 is being squared. And if 12 is 2 times 3, then this whole thing is a perfect square. 2 times 2 is 4 times 3 is 12. This is, in fact, a perfect square. So how do we decide how to factor it? All right, what's being squared up front? 2x squared gives me 4x squared. So 2x is first. 3 squared is 9. And then how do I decide if it's a plus or a minus? It's going to depend solely on that plus sign right there. That means that this is 2x plus 3 in parentheses squared. Okay, so what does this give us? Well, before I move on, let me make a really quick comment. If this strategy is not your strategy, you don't have to use it. Think through. 4 times 9 is 36. What are factors of 36 that add up to 12? 6 and 6 add up to 12. So if I had written this out the full way, you would see that the inside 2 terms are going to give me a 6x. The outside 2 terms are also going to give me a 6x, which adds up to that 12. The point is, at the end, you want to just make sure you write this as a squared to help you with the multiplicities part of the question. Okay, so what does this tell us? Well, if x squared equals 0, that means that just x equals 0, but the 2 up there tells us that we're dealing with an even multiplicity, specifically a multiplicity of 2. 2x plus 3 squared equals 0. I can just look at the 2x plus 3 part. That means that x is negative 3 halves. And if x is negative 3 halves, I'm still at x equals negative 3 halves. I'm still dealing with an even multiplicity because there's a squared up there as well. All right, I've told y'all before I care a lot about graphs. So what does this say about the graph? Even multiplicity means it's bouncing off at 0. Even multiplicity means it's bouncing off at negative 3 halves. We have a double bounce. We never are crossing through the x-axis. Since this is a polynomial and it's never crossing through the x-axis, it's either all greater than or equal to 0 or all less than or equal to 0. If you plug in most points, you could try plugging in 1. If you plug in 1 to your function, you'll get a positive number, which tells you that this graph is always going to be greater than or equal to 0. Now, did that have anything to do with the question? No, I'm just giving you fun facts on the side. Okay, so how do we answer the rest of these questions? Well, the next question is the end behavior. This is an x to the fourth graph. We have a squared and a squared. The original equation says x to the fourth. X to the fourth graphs have end behavior, even degree, that's the word I need, even degree, which means they're either both up or they're both down. In this case, because it's a 4 up front, that means my end behavior are both going to be up. Okay, so as x goes to the left, negative infinity, the h of x is going to positive infinity. As x goes to the right, or to positive infinity, h of x is also going to positive infinity. All right, maximum number of turning points. So x to the fourth graphs. They potentially can look like a W or they can look like an M. Sometimes they just look like a really flattened out parabola, or they do like weird roller coaster shapes. The main idea is that the fourth degree polynomials, if we subtract 1, we have maximum of 3 turning points. So that's our last answer, max of 3 turning points.